Welcome to the first Algebra Skills video. These videos are intended to cover important topics that don't quite fit into the class schedule. Along with these videos, you'll find dozens of practice questions that are intended to be completed on your own outside of class. These practice questions are completely optional. They're not worth a part of your grade. However, if you check the course calendar, you will see that there are algebra skills evaluations. These are intended to be completed in class on Fridays, and these are worth a grade. It's up to you if you want to watch the rest of these videos and go through the practice problems, but I would recommend that you give them a shot. Make sure you understand the material so that you can succeed on the algebra skills evaluations on Friday. This section we will have a number of videos covering topics involving fractions and functions. So let's dive right into it. Let's start with the definition of an exponential expression, a to the n, which represents the number a being multiplied by itself times a times a times a n times. If we can use this definition to evaluate a number of expressions. For example, 2 to the 3, that would be 2 times 2 times 2, 3 times, and we can do that in our head. 2 times 2 times 2 is 8. That means 2 to the power of 3 is 8. Similarly, we can look at negative 3 to the power of 2. That will be negative 3 times negative 3, only 2 times. And negative 3 times negative 3 is positive 9. When we're raising something to the power of 2, we can also call it squared. So we could say negative 3 squared is 9. This works even when the thing that we're squaring is a fraction. For example, 3/4 squared, that's just 3 over 4 times 3 over 4. And if we multiply these through, we get 9 over 16. Or we could type it into a calculator. When we're dealing with exponents, we have a number of very important rules that you should remember. For example, anything to the power of 0 is 1. So that means 2 to the 0 is 1. 1 million to the 0 is 1. And you can think of this as something multiplying by itself 0 times is just 1. Next, we can look at two numbers being multiplied together, two exponents being multiplied together that have the same base. A to the n times a to the m. Well, it turns out as long as the bases are the same, we can just add these exponents, a to the n plus m. Similarly, if we're dividing two exponents that have the same base, a to the n divided by a to the m, we can just subtract the exponents. Next, we'll look at what happens when we have an exponent of an exponent. If we have a to the n raised to the power of m, then we just multiply those exponents together and we get a to the n times m. This also works if we have a to the m to the power of n. The same thing will happen. We'll get a to the m times n, which is the same thing as before. And lastly, if we have a negative exponent, like a to the power of negative n, we can get rid of that negative sign and put the exponent in the denominator instead. And if the negative exponent already is in the denominator, we can get rid of the negative sign and throw it in the numerator instead. So anytime we have a negative exponent, whether it's in the numerator or denominator, we can get rid of that negative sign by taking the exponent and putting it in the other one. Let's practice using these rules by simplifying these expressions. Let's start with the first one, a to the 3 times a to the 5 divided by a to the 4. We're going to use two different rules here. Our first one, let's just focus on the numerator. A to the 3 times a to the 5. We know from our last slide that if we have two exponents with the same base being multiplied together, we can just add the exponents, a to the 3 plus 5, which is a to the 8. That means this expression is now a to the 8, and then our denominator is still a to the 4. But we have a rule now that says if we have a quotient of exponents with the same base, we can just subtract the exponents. This will work out to a to the 8 minus 4, which is a to the 4. This entire expression simplifies to a to the 4, and remember the definition of that is a times a times a times a 4 times. Let's look at the second one. It's a little more messy. 12x squared y cubed divided by 6x to the 4 y to the negative 2. I'm going to start this one by grouping our terms as numbers, powers of x, and powers of y, and working on those individually. For our numbers, we know that 12 divided by 6 is just 2. So let's keep that in our back pocket. And when we have x squared divided by x to the 4, we know from our rules of exponents that's just x to the 2 minus 4, which is x to the negative 2. And we'll remember that. And then the tricky one is we have y cubed over y to the negative 2. Now there's a couple things we could do here. We could either say this is a quotient and let's subtract, or we could say y to the negative 2 in our denominator, that's the same thing as y to the positive 2 in our numerator, and our rules of exponents tells us that's this y to the 3 plus 2, which is y to the 5. Putting this all together, we have 2x to the negative 2 y to the 5th, 2x to the negative 2 y to the 5th, and if we don't like that negative exponent, we could always use our rules of exponents to put it in the denominator, and we could have 2y to the 5th divided by x squared. Either of these are totally valid. They're both mathematically correct.